Good evening, Minaga.
Good evening.
Okay, so we just talked from operator precedence, yes. Right, then actually, so the basic operator type that we have learned is arithmetic operator, mathematical calculations, right? Arithmetic operators. Then, so today we have to learn about the comparison operator, and after learning comparison operator, I'll be shifting into assignment operator, right? And membership operator. Because logical operator and bitwise operator, you need some idea about other number systems like binary, hexa, octal. So then we can successfully do this bitwise operator part. Then and or not, I think you need some logic gate knowledge that can be given. So that is like easy. So rather than just learning number systems and coming back, so we can learn just logical operator part. So we have to drop the bitwise operator for the moment. Other things we can do. So let's start with the comparison. Okay. Right.
Okay.
Comparison operator, basically it can compare a value, right? So value means it can be integer value like 7 greater than 2. So it says true. So we learn about the true and false yesterday. True is basically it has a value. It's 1. False is 0. False is 0 and true is 1, right? So that we have learned. And so you can compare a decimal number and you can compare binary number. So anything you can compare. And also a scientific number, E, let's say plus 4 and E plus 4 and let's say 2.3 plus 5. Oh, it's F, not F, it's E. Okay, it's E, here, E. And you can see it's false because like, so if I check if is it like equal to, you have to check with 2 equal signs. It's saying it's not equal. So if you want to check unequality, like whether it's not equal, you have to use not an equals. Not is denoted by this exclamation mark and equal mark. So it says not equal. So it says true because those are not equal. So if I compare and ask whether is the first number less than the second, yes, it's true. And first number less than or equal. To check that, we have to use both symbols because in mathematics, there is a symbol like this for less than equal. There is a symbol like this. But here in the computing, you don't have such. So you have to use less than and equal sign both, right? So for greater than and equal also, for greater than and equal in mathematics, you have something like this. But in computing, you have to use greater than and equal. So both symbols, right? That is something different. So other things, I think it's easy. The first one is checking whether it's equal to. The second one, not equal to. This is less than, greater than, less than or equal to, and greater than or equal to. So is it okay or do I need to explain further? So what do you think? Okay. Yes, I
Yeah.
hope. Okay. So this, in addition to the numbers, text can be compared. For an example, so let's compare hello, whether hello greater than hello. So that can be done. So it says no because hello is equal to hello, right? So if you check hello equal to hello, yes, it says yes. Hello not equal to hello, no, it says no. But if I check hello and hello, so then it says yes because one has a capital letter, the other one has simple letter. Therefore, it says it is not equal. And also, if you check whether hello is greater than hello, it also said true. Or hello is greater than or equal to hello, it says true. So what's the reason for this? Simple hello is greater than capital hello. What's the reason for this? Yes?
I'm not sure.
Not sure, I don't know. So the thing is, like we learned that later, last day, right? I said that you can get ORD of a character. So let's say ORD of simple H, it is 107, and ORD of capital H is 72. So it compares this character value, right? So that is the reason why it's giving the simple hello is greater than capital hello. That is by comparing the character value, right? So if
Yeah.
both are equal, right? Okay, let's say both are equals. One is hello and the second one is hello. And you are checking for the greater than-ness, it says false. But let's do something like this. First one is hello, the first one is heli, the second one is heli. So O is greater than I because I is coming first and O is next. So it says, yes, it is true. So if first character is same, second is same, third is same, fourth is same, it will at least try to find the last character and compare. So if they either false, it will be considered. Understood?
Mm-hmm.
Right? So because this O, ORD of O, ORD of simple O is O come first, O comes like O come last, and I come first. So then here I is 105 and O is 111. So that is the reason. Okay, I think you can write down these examples while you practice. You can write down the examples from here to here, highlighted. So you use the idea about the comparison operators. You can write down subheading comparison operators. Then please give the results. While practicing, you can write down this in your book. This is about the comparison operators. Right. Logical operators. So logical operators, so there are three, actually these are coming through the, so have you learned logic gates in your mathematics lesson? Logic gates, AND gate, OR gate, NOT gate. Have you learned that?
I'm not sure.
Okay, I'll show the logic first, then because this you need in future programming, you need this. Therefore, I'll show you this and not the O and not logics first, like so how it happens. So let's use a circuit construction kit. Okay, this is an educational tool. You can use this website. Like there are a lot of educational tools there. I'll be sending you the link. Okay, you got the link? I have sent it in the chat.
Yes, I got the link.
Okay, so there you can go to the introduction. Actually, this is very simple interface where you can do some simulation, right? It has a voltmeter, ammeter, and so these electronic elements, basic electronic elements. This is like kids electronics. So let me take a battery, and also let me take a bulb and a switch. Actually, I'm going to take two switches, and I need a wire too. So I need few wires. Let me take a wire. So this minus signs come in because of the electron view is selected. But if you don't like that, you can select the conventional one. And that then it only shows the conventional. So let's select conventional and let's have some copper wires to connect this. You can do this with me. So it's easy. Then just extend this wire and I just want to connect this to this. Then this switch to this switch, and finally the battery to the switch. Okay. So this is what I made. So okay, can you tell me, so if I want to turn on the bulbs, what should I do?
You should connect the switches.
Is it one switch or both switches?
Both switches.
Yes, obviously. So I have to connect this one with this one. So then you can see the conventional power supply is there. So the bulb will turn on. So that is very simple logic. So if there are two switches serially connected, definitely you need to turn on both switches to get the supply. No other way, right? If you try to turn on this won't work. This won't work. Both open, it won't work. So, but both closed like this, yes, it's working. So let's say I'm going to introduce another switch. Let's say I'm going to have 3 switches now, and I'm now going to connect this with this, and another wire to connect. Now I have 3 switches connected in serial manner. So that now what I need to do? Can I turn on 2 switches and get the output, or do I need to turn on all 3 switches?
To turn on all 3 switches?
Yes. Here you can see need all 3 switches. Right? 1, 2, 3. All 3 switches needed. So that is the nature of AND gate. That is the nature of AND gate actually. So let me use another site. So this is a logic, another simulation site. Right? You can just bookmark the previous one. This is from Colorado University. I think it's in USA, right?
Yeah.
So then this
Yes.
logic.ly, another one. So there you can just close. Okay, sending you the link. Okay, please look into that. Please open that as well. That is also a very good simulation interface where you can use this for coding. So the trial version you can use. You can, if you want, you can buy the professional version, but that is not required. Just have the trial version. It's enough. Okay, there you can get the logical symbol for that. Actually, this is the logical symbol for AND gate. Here you can see this is logical symbol for AND gate. And let's supply 2 inputs, 2 switches to supply 2 inputs. Let's connect this with this. Now 2 switches are connected. Let's connect a bulb to see the output. Okay, considering about the AND logic that we learned, in order to lighten up this bulb, what you need to do? Just think about the previous concept that we learned. If you want to light up this bulb, what we need to do?
You need to flip the switches?
Both, right? 1 and 2 both. So it will light up. So this you can actually show using a table. This is called a truth table. This scenario you can show using a table here. If both are false, the output, this is O1 is the output, is false. If I2 is true, still false. If I1 is false, still false. If both I1, I2 are true, then the output is true. So only if both are true, then the output is true. Okay, that is the logic related to AND gate. Okay, then let me take another AND gate, and I'm going to increase the number of inputs. That can be done. Here you can see AND gate input count. I can increase that. So let's increase to 3. Now 3 inputs are there. So when there are 3 inputs, I can use 3 switches. So these switches are actually providing the inputs, right? That is why the symbols. So just connect these 3 inputs to the 3 switches, and let's connect a bulb to see the output. You can see all 3 are off, bulb is off. This one is on, still the bulb is off. This one is on, still the bulb is off. This is on, still the bulb is off. Both are on, still the bulb is off. These 2 are on, still the bulb is off. These 2 are on, still the bulb is off. And all 3 are on, then the bulb is lighting up. So this can be explained after selecting this. You can select the truth table and see the truth table. So since there are, sorry, I have to select 3. Be careful, don't select 4. Let's select this tree and the bulb. And then select the truth table, and you can see, so there will be 8 combinations. false, 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 true, false, true, false, false, true, 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 false, false, true, false, true, 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 false, and true, true, true. But only if all are true, this is true. That is the nature of AND gate. Actually, this is interchanging. You can easily do this, draw this diagram. So this is actually, you can say false, true, false, true, false, true, false, true. Downwards balance. False, true, false, true, false, true, false, true. This one, false, false, true, true, false, false, true, true. This one, false, 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 true, 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 true. It always double. Here 1, here 2, here 4. Then next one comes, it will be 8. So how many combinations? There will be 8 combinations. 3 inputs, 8 combinations. But only in this way, this stage, it will produce 1. So this is called AND logic. This is called AND logic. Understood the AND logic? AND logic means if there are conditions, all conditions must be true in order to get the output as true. Understood it?
Yes.
Okay. So have you learned this in your school for mathematics or some other subjects?
Yes, I have.
Right. So then I think no need to give a note on this, right?
No.
Okay. So then can you remember the OR logic? Not much. Can you remember the OR logic, the next logic? So there are 3 logics. AND logic, OR logic.
OR logic. I don't think so.
Okay, let's see. It's okay. Let's see. So are you using this kind of tools when learning schools or only the board? So I don't know the education system there. So what kind of system is there? Are you using tools to learn this, or are you just using? Yes.
We're using mostly boards.
Mostly boards. Similar in Sri Lanka, right?
Yeah.
It's much similar, right? But so there might be differences, but like so as your father said, yes, it's much similar. But like but in the some countries I have seen they're using tools. So they just use these kind of tools. Like that is why these developments are there. No? The simulations are there for learning purposes, right? So I think this way is better. That is my personal idea. I don't know, because as a student you can decide, because this is actually learning by some experience. No? Then you can easily remember this, right? So that is what I prefer personally, but it depends. It depends. Like if you can remember just by doing board, so that is okay. So here in OR logic, so let's use same 2 switches, but this time I'm going to connect them parallelly, not the serial way. This is going to be connecting parallel way, like this. Okay, this is what I'm going to do. Okay, now tell me, if I want to turn on the bulbs, what I can do.
I can only put in. You can put in either one and it works.
Yeah, either one. So this will work, because you can see the conventional power will move through the first switch as it is complete circuit. So if I turn on this, like it's going to complete to this path. So still works. So what about turning on both? Will it work?
It will still work.
Yes. It's working. Like there are 2 ways, but doesn't matter. There are 2 ways, but doesn't matter, right? So this is the OR logic, right? If there are 3 switches, same. So if you connect parallel way, if there are 3 switches, the same will happen, right? This one, or either this one, or either this one will work. Or if you turn on both, still work. If you turn on both, still work. These 2 still work. These 3 still work. So, but only situation where it's not working is when all the inputs are off, or all the inputs are not there. That is the opposite logic of this OR logic. The AND logic is considering all the inputs. It needs all the inputs to produce the output. Right, let me write down, this is summary. AND gate will output 1 if and only if all inputs are 1. So this 1 is another name to tell true, right? So that is the AND logic. And let's try OR logic. So there are a lot of logics, but here in this level, you need to learn about only 3 logics. Let's take OR gate, this one, OR gate, and have same 2 switches there. Let me connect the switches. And you know the result of OR logic. So when I turn on either, this one works, or both, it will work. So the truth table for this is something like this. It only gives false if both are false, otherwise it's true. If both are false, both inputs are not there, otherwise it's. So same will be there, same is there, same situation for 3 inputs. So let's use 3 inputs, increase 1 more. Let me connect. And then the bar. You can see this works, this works, this works. Both yes, and both yes, and all 3 yes. But if all are not, no. So that means the truth table says here, if all are false, false, otherwise it's true. So this is how we can remember OR gate easily. So the logic is, can say OR gate will output 0, that is false, right? If and only if all inputs are 0 or false. Otherwise, in every other occurrences, it's 1. Right? So in 3 inputs, there will be 8 combinations. When there are 2 inputs, 4 combinations. That has an equation, right? So 2 inputs, 2 to the power 2 means 4 combinations. When there are 3 inputs, 2 to the power 3, 3 inputs, 2 to the power 3, there will be 8 combinations. How to write these combinations? That also has a pattern. You can write as 0, 1, 0, 1, 0, 1, 0, 1. So that has a pattern. This is the first digit. The second digit you can write, you need to write 8 combinations. 0, 0, 1, 1, 0, 0, 1, 1. The third digit you can write 0, 0, 0, 0, 1, 1, 1, 1. So that is the third digit. So the output digit you can write. So what is the output digit for AND gate? Yes. Output for AND gate.
The output for AND gate?
Yeah, I'm asking. So if all inputs are 0, output will be?
False.
Yeah, 0. So then 0, 0, 1, still?
0.
0. Still 0, 0, 0, 0, 0. But here in the last one, it's 1, right?
Yeah.
Okay, that is AND logic. So whatever I'm writing in the red color, you can just write. So this is AND. And so if it is OR, if it is OR logic, I don't have enough space. Okay, let's write down this. O logic, this will be first occurrence, it's 1, but other 0. All occurrences, it is 1, and that is the O logic. And this is, so you have 3 inputs, I1, I2, and I3 are just 3 inputs. So this is I1, I2, and I3. So the 8 combinations are this. This is the AND logic, and this is O logic output. So it's not a proper one. You can take more space and write down. This is, my one is like narrow. Okay, then these special statements, please write down these 2 special statements, this AND statement and the OR statement. That is also required, you need to know that. And about the number of inputs. So this is the way that we calculate the number of inputs. If number of inputs 2, there will be 4 combinations. If number of inputs 3, there will be 8 combinations. This is summary actually. You can take a screenshot as well, but better you can write down this in your book, saying logic gates. The main heading is logic gates. And there are 2 logics that we learn, AND logic and OR logic. Not logic is easy. I'll explain that after you write this. Not is easy. Not is simply inversion, the reverse. Right, let me show.
This meeting is being recorded.
The not is so very simple. It has 1 input, 1 output. Right? Only 1 input, 1 output. That is the simplest form, but it will invert. So here, this is not gate. It has 1 input, 1 output. It's very easy. So if you are having a switch and a bulb, so what it does, it will invert. Then here is 0, then this will be 1. If it is 1, it will be 0. That is inverted. Right, so not gate. So what is the logic? Not gate will invert the output. So if input I1 and let's say O1, and if I1 is 1, if O1 is, sorry, it's 0, then O1 is 1. This is 1 and this will be 0. So that is the inversion process happen, not gate. So simply it will, you can combine them and create more logics. Right, you can combine them, create more logics. Take down this as well. How can we combine them to get more logics? So actually this lesson comes in mathematics as well as basics in engineering.
Hello?
Yes, Putin. Have you finished?
Oh, yeah. Yeah, I am.
I was waiting for you.
Oh, okay. We finished.
Okay. Then, so let's combine and see. So let's combine and with not. or with not. So likewise, you can combine any, like you can combine O with and with O with and not. Any combination. So this is actually, this is going like, so when you combine the logics, let's say let's have a note. So it will create the other gates. But other gates, we are not going to learn that stage, but you will be learning this in future. So when you are doing that, please remember the same logic applies. So let's combine these two and with not. So let's have switches. So whatever you get through normal and gate will be inverted. So that is the simple thing that you need. AND gate, normally, you know, if both are 1, it is 1. That is AND gate. They come 1 and 1. If both are 1, it is 1. So both are true, it is true. But here it's reversed. Why? If both are true, it is false. Because it reversed. If both are true, it's false. Otherwise, it's true. Right? It's inverted the original output of AND gate. Here, if you combine OR gate with NOT gate, again, OR gate with NOT gate.
Yeah. OR gate with NOT gate. If only one of them is on, then it will be like false.
Not only that, both are on, then also false, right? So
yeah,
it's easy to say other way. If both are 0, it is 1. Otherwise, 0, right? I think that way is easy. If both are 0, so earlier if both are 0, output was 0, no? Can you remember the statement that I have given?
Yes.
There I said that if both all are 0, it's 0. If all inputs are 0, the output is 0. So here it's the reverse. What is the reverse? If all are 0, output is 1. Yeah. If both are 0, this situation, right? If both are 0, output is 1. Otherwise, 0. Otherwise, false. If both are 0, this is 1. Otherwise, 0. Yeah. In all other places, 0. So that is easy, right? Rather than saying in either one is 1, that is false. So this is also either one's false, but here both, then also false. You have to tell three. No, there you have to tell at least 2. Either one is true, then that is false, or both are true, that is false. At least you have to tell 2 statements. Rather than telling like that, you can say if both are false, that is true, or if all are false, that is true. Otherwise, it's 1. Sorry, otherwise it's 0. If both are false, it is 1. Otherwise, it's 0. So that is easy. Okay, that is this, and you can combine like this. Yeah, so all these combinations are supported. Let's say you are combining like this and you are trying to get the combination logic like this using OR gate. And here you can see there are 1, 2, 3, 4 inputs. So you can some inputs you can combine even. Here you can combine. So likewise also you can give independent inputs. So likewise, it is making this complex is it's not a big magic. You can make the logic complex and then ask, so what is the output? This is in the logic gate lesson. If you are learning this in future, you have to face this kind of situation. There will be 3 inputs there, so there will be 8 combinations. So what will be the output in these 8 combinations? That will be asked in the examination. Right? That is actually in the logic case. You have to decide. You have to decide what will happen. So one by one, you need to write down. So that is the only way of solving this. So because it is not easy, now you have like few more. So then what? If there are a few more, then what? You need to do. Let's say this A, B, and C are inputs, and then the final output, let's say, or let's have intermediate output, A and B. This is the symbol for A and B. A or B symbol is A or B. This is the symbol for A or B. A and B is coming here. A or B is here. And you have to O both. You have to O both. That means A and B O AOB. A and B, O, AOB. So that is the final output that you are getting. Right, this is the final output. Actually, how it happens here, you have A, B, C, let's say. It's easy to use one letter, that's why I'm using one letter. A, B, and C. And this is what? This is AND gate. You can say this is A and B. And actually, this is not A and this is A and B. So I have done some mistake. So this is actually AOC. AOC. Because it comes, it's not D or A or B, it's actually AOC. This is A and B. AOC. Here you get A and B from the top layer, or from the top wire, and from the bottom wire you are getting AOC. Actually, I have done the basic mistake. AOC from the bottom wire. So then actually this need to be reformatted. So I can say you have three inputs, A, B, and C, then A and B, then actually AOC, then the next one is within bracket A and B, O, AOC. So this is how it draws, AOC. So since there are three inputs, there will be 8 combinations. You know how to write down this 0, 0. Let's write digit by digit. This is easy. Let's write digit by digit. It is 0, 0, 1, 0, 1, 0, 1, 0, 1. Third digit. The second digit you can say 0. 0, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, for then the first digit 0, 0, 0, 0, 1, 1, 1. So that is the first digit. Okay, now you have A, B. A and B. What you need to consider in A and B? So let me color. So then you can identify this easier. A and B. A and B means this and this. So what is the logic? AND gate logic. Yes. So can you tell me the statement that I made earlier? What was the statement? If all inputs are true, or if all inputs are 1, AND gate will output 1, right?
Yeah.
So all are 1. Which situation all are 1? All are 1 in this is 0, 0, 0, 0, 0, 0. This situation all are 1, you can see. And this situation all are 1.
Yeah.
This and this. Right?
Yes.
All means A and B. Actually, A and B will considered here, no? Then A and B are 1, this one. So you can write down 0, 0, 0, 0, 0, 0, 1, 1. So that is the output for A and B. AOC, AOC, A and AOC will be considered. Actually, OR gate logic, you know. What is the OR gate logic? If all are 0, the output is 0, right?
Yeah.
All are 0. Here all are 0. Here also all are 0. All are here, no, 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 no. If all are 0, output is 0. Okay. So you can write down this. If all are 0, output is 0, otherwise it's 1. Okay, then you have again O logic. O logic of both. O logic means, you know, if all are 0, so that is the situation. All are 0, which situation? Here. Both are 0. Here also, both are 0, right? But in all other situations. So then, so you can write down this as 0, 1, 1, 1, 0, 1, 1, 1. Actually, you can discard 1. So when you write the final output, you can see you can discard. You can discard other gates. AOC is enough. Why? Anyway, the final output is similar to the AOC output, right?
Yeah.
So that means, so if equation is given in mathematics, AB, O, A, O, C, actually speaking, so this is equal to AOC, right? This is equal to AOC. Because A and B will not be considered. A and B will not be considered. It's ultimately AOC. You can understand by this truth table. Just have a snapshot, or just if you want, you can write down that as well. So this is needed because like this part will not be there in programming, but actually this comes in the basic electronics. I don't know whether you're aware of the computing degree if you obtain. It's falling under electronic engineering. Right? Computing degree is falling under electronic engineering. So you can register with IEEE. IEEE. What is that?
I'm not sure.
Institute of Electronic Engineers. That is the world's largest union of engineers. IEEE. They are forming again. They are making standards here. The world's largest technical and professional organization, having like 501 professional association for electronic engineering and electrical engineering. But this is in New York. Right? Operations are in New Jersey. Right? So you should know, right? Okay. Anyway, so that is what? That is Electronic and Electrical Engineers Association. So they are actually making standard for electronic engineers. If you are done, if you have completed not all the IT degrees, but if you complete this science-related IT degree one day, you can register with them as a professional member, Institute of Electrical and Electronic Engineers. Right? You can get the membership of them. So actually, this part coming under electronic engineering basics. It's the fundamentals of electronic engineering. Why? Actually, this is how these integrated circuits, you know, ICs. Do you know ICs? IC integrated circuit. Are these circuits?
Oh, I've seen them, but I've never.
Right. Okay. Anyway, in any electronic device, so not any electronic device nowadays. Now you know it's composed with, or it is a creation. So the fundamental unit there is transistors and ICs, and large ICs or processor, whatever, all made up with these logic gates. Can you see inside there? You can see the logic gates.
Yeah.
Right. So that is why I said it is fundamental to electronic device. So there are AND ICs, NAND ICs, O ICs likewise. So this is actually O based IC. This is O gate based IC. And this is also O gate based IC. So these ICs you can purchase, right? These ICs you can purchase and utilize. This is AND based IC. So shall I erase the note, or do you need time to write down that?
No, I got it.
Okay. I'll erase. You can see this is AND based IC. The IC 7408. It has AND logic inside, but you can't see them. You will get a chip like this. You can't see what's inside. But when you're learning electronics, you will learn. So what is behind that? So what is behind these things? This is 7402 code NO, and this is code NAND. So likewise, this is O gate based IC. So these ICs are available in the market. When these ICs are combined, it creates something called LSI, large scale integration. Large scale integration. This is LSI. Actually, ICs together form LSI. These LSIs are in the motherboard, processor, so related things, or this, in mobile phones, electronic devices like washing machines, these LSIs are there. Then these LSIs are taken together and VLSIs were created. So VLSIs, so you can see this is very large scale. LSI means large scale integrated circuits, large scale ICs. This is very large scale ICs. You can see there's like a lot of pins. This is VLSI. This was also used in computing and electronics. And nowadays we are using ULSI, ultra large scale integrations or microprocessors. Ultra large scale, this is VLSI. And now it has come to ULSI, ultra large scale integration. So a lot of ULSI, if you see the logic diagram, I don't think that you can visualize that within a page. Oh, no. So that is actually a lot of logic gates combined into this to creating ULSI. Actually, ULSI is, here you can see, inside ULSI, there are ICs, right? ICs and VLSIs. So it is really complex logic, and the fundamental to this complex logic is the basic logic gates, right? Fundamentals to this complex logic is basic logic gates, and that is how electronics made. That is how circuits, hard disk, memories, processors, all made with that mechanism. Okay, I think you have clear idea about what is this logic, because before learning the programming, you need to understand, so what is going on with hardware, right? Logical operations. Here, I have given very simple definition, but now you know a big picture. Now you can imagine a big picture when you're reading this. And will return true if all conditions are true, or will return false if all are false, not will invert. Okay, so let's see. So this is very simple. I had to explain a lot. This is very simple. It means, okay, so let me tell, 3 greater than 2 and 4 less than 8. So what do you think? Is it true or false?
It's true.
Why? Because both are true. So let me make one statement false. So I'm telling 3 greater than 2 and 4 equal 8, but 4 equal 8 is false, therefore the entire statement will be false. Similarly, but if you use OR gate here, so what will be the result?
It will be true.
It's true. Why? 3 greater than 2 is true, therefore it's true. So when you're comparing, okay, I'm asking this, okay, I need to do this and not this. Then 3 greater than 2 and not 4 equal to 4 equal 8. Then what? I'll combine. Yes? Then what? So 3 greater than 2 is true, right? 4 equal 8 is false. But not of false. False again, not of this false will be true, right?
Yeah.
Understood. So I'm taking not of this. So this is not true now. 4 equal 8 is not true. Not of false will be true. Then true and true will be considered, and the final output will be true. Understood?
Yes.
And you can write like this also. I can ask whether this is, it says false, then I can ask not of whole thing. Not of whole thing. Not of this logic. That is also true. Because if answer is false, then you can invert that using a NOT gate. Understood how these logics are used?
Yes.
It's simple, right? It's very simple. But only thing is, when you dig into And if you are going to learn the fundamentals, basics behind that, so that then only that will become a big chapter. Actually, you need that since you are learning for ICT, and one day, I hope at least you have some intention to get a qualification related to ICT. It's falling under electronic engineering. Therefore, you need to know the basics there. Okay,
Yeah.
That's it. And now you know the logic operations. Assignment operations. Membership of operations, of course, it's easy. Let's finish membership operations quickly and then go to the assignment operations. Membership, you can say here, H in hello, H in hello, or you can double quote. Right? You can check for the presence, H, or double quotation is also H in hello will be false because you don't have capital H there. You can say, then you can say H O H in hello. Sorry. Right, silly. It says like HOH in for hello. It says false because HOH will be, you don't have such thing. Right, that is why you can't write like statements. Right, therefore be careful when you're writing like this, but you can still write not. So you can say H not in hello. That can be done. H not in hello. Yes, true. H not in hello. So this is membership operations. You are checking the presence. Numbers also you can check. You can say 1, okay, 10 in. You can give a set of numbers. Oh, 10. Bracket. 10 in this. It says false. No, 10 is not there. So let's add 10 and see. So this is accurate searching. Then says true. When 10 is there, it says true. You can check the presence membership operator, whether this given member is a member of that, whether the given value is member of this set or list or whatever the given content. So that can be done for file as well. Right, we'll do that in the file reading. You can open a file and search for file. Right, that powerful operation is there in Python. Right, you can, okay, let me show a small sample and, okay, let's say I have a file like this. It's in Atom. Let's say, let's check something else, brackets. I'm going to create small file, which has my name in it. And this should be text file, right? Whatever, you can use Nano or whatever text editor in your, okay, this is HTML file, right? You can see this is HTML file. I'll be, I can just erase all these things again, take a new file. So let's make it simple. I'm writing my name there. I'm going to save this file in the documents. I'm going to save this file in documents. I'm going to save this as dasun.txt. You can use whatever editor that you're using, Nano or Cat, so not Cat, like Nano or any other editor in Linux. So let's save this in documents. Dasun.txt, I'm saving it. Okay, now it's in the documents. So let me take a new file in Python. I'm going to open that. So let's say f equal open Dasun.txt. I'm going to open. Then I can read the file. F.read. Then I can say if not if, I'm just getting faint. Dasun in output. So this is a very simple program. Just checking the membership. Let's save in the documents some name. Let's run the file and see. You can say it's true. It says true means my name should be there. So you can search very large file like this. It says true means in this file there's something called Dasun. You can read the file. So let's say Nilanjana in this. Run the module. It says true. Nilanjana also in this file. So let's say something else like Pavan. Save it and run it. And when you run, it says false. No, Pavan is not there. Likewise, you can check a file without even seeing the file. You can read it using Python, and then you can check the file whether the particular word is there in that file. Right? That can be done. So we learn this in like further. So we need to learn actually this file reading, file writing subjects. This part is a different part. We have to learn. But anyway, I think you have idea about membership operators now. Now we have two remaining, that is bitwise and assignment. Bitwise, you need actually binary knowledge to do that. I'll be doing that later. Assignment operators, I think we can do that next day. And with that, the particular section will be over. Then we can move to the selection next day. Just after finishing that part, we can move to the selection. I'll be sending you the note. Right? I'll send you the note. Just go through that and practice. Then see you next week. Okay. Bye.
Bye.